Hello everyone, welcome to In 5 Minutes. In this video we are going to see the type 2 of higher order differential equation. So in type 2 our x is nothing but this value. So what is x? We know that our higher order differential equation is given by f of d into y equal to x. In this case x is sin ax plus b, or it can be cos ax plus b. So the solution for this equation is given by yc plus yp, where yc is the complementary function and it will remain the same as we used to do for type 1. Only the change is yp. The general formula for yp is 1 upon fd into x. In our case it will be 1 upon fd into, instead of x we will have sin ax plus b or cos ax plus b. In type 1 we used to represent fd in factorized form and we used to substitute d equal to a. In this we will represent fd in terms of d square. So fd is a polynomial of d cube something d square plus d. So we will represent fd in d square, which will called as function of d square. So in type 2, remember, in type 2 we represent fd in terms of d square, so it will become function of d square. So this will be function of d square and this part will remain the same. So in this part we are going to substitute d square equal to minus of a square. What is a square? A is nothing but this part, x into a. The coefficient of x in sine term is what we are going to substitute, d square equal to minus a square. So this part will become minus 1 upon phi of minus a square, and this part will remain the same. Provided phi of a minus a square is not equal to 0, then only this equation will be valid. Then here, as we used to have phi of a not equal to 0, then this equation was valid. Then we have phi of a equal to 0, then we have x raised to r upon r factorial, something like this. Similarly here, when phi of minus a square is equal to 0, what we are going to do? So when our phi of minus a square is equal to 0, then our equation was d square plus a square raised to r. When we substitute here, it is a phi d. When we substitute d square equal to minus a square, so this part will become 0. So therefore we do not substitute this part. So this part is creating problem, and the solution for this problem is given by minus 1 the whole raised to r x raised to r upon r factorial. This is a very complex equation. Here we have 1, 2, 3 terms. Minus 1 raised to r to x raised to r upon r factorial is of type 1. Here we add two things, minus 1 upon r and 2 into a the whole raised to r. What is a? From here we take a is nothing but this a. So this will be the solution when our phi of minus a square becomes 0. And here we used to have cos ax plus b, or we used to have sin ax plus b. Then this part will be this, and again we will have sine or cos in that matter, and the angle for this will be ax plus b will remain as it is, plus we will have pi by 2 into r, where r is this power of this part which is creating problem. This will be more clear when we see the problem on this type. So the problem on this type we will see in our next video, so stay tuned for our future lectures.